Hi everyone, welcome to the calculator paper. So we will get straight into it. Now starting off with question 1, we are asked to work out 0.06 million divided by 6.2 thousand. So putting this into our calculator, what we will be putting in is 0.06 times by 1 million divided by 6.2 times by 1000. When we put this into our calculator, we are given 9.67474193. We are asked to give our answer to two decimal places, so we're looking for the first two here. But because our third decimal place here is 7, which is bigger than 5, we need to round upwards, which means our answer here would be 9.68 decided by this number here. So our answer would be 9.68. I do apologize. Now question 2 is asking for 3 divided by 87 as a decimal correct to 3 decimal places. When we put this into our calculator, we are given 0.0344827. So I'll put a couple decimal places in here now. So 0.0344827. We care about 3 decimal places, so we want after the decimal, we want 0.034. Now the fourth decimal place, number 4, is smaller than 5, so we do not round upwards in this case. We leave it as 0.034. So the answer here would be 0.034. For question 3, we are given a building. Which one of the above shows the elevation of the left side of the building? Now, what we need to do is pretend we're standing at the left of the building here and looking at the building. What do we see? Now, if we're standing on the left here, we know that the bottom is going to start off with a square, and it's going to be a head-on square because we're stood on the side here. Now, the top over here as well, we're not going to be seeing a triangle because we're going to be seeing what's over here, just on the left-hand side. So essentially, we have a square on this side, and we're also going to be seeing a square at the top here. So the elevation from the left-hand side is going to be equivalent to number C. It's not going to be slanted in any way because just standing from here, we see exactly what C would be. So the correct answer here is C. Moving on to question 4, we are asked what is 1 meter cubed the same as in terms of centimeters. So what we do is we start by converting 1 meter into centimeters. So 1 meter is equivalent to 100 centimeters. So 1 meter cubed is equal to 1 meter times by 1 meter times by 1 meter. So what we have here, to convert, 1 meter is equal to 100 centimeters. This would be 100 centimeters times 100 centimeters times 100 centimeters. So 100 centimeters times by 100 centimeters times by 100 centimeters. This is equivalent to 1 million, and we have 3 centimeter values being multiplied together, so the unit here would be centimeters cubed. So the correct answer would be D. For question 5, we are told that a social club sells 50 pink raffle tickets and 75 yellow raffle tickets. Tickets are drawn randomly. What is the probability that the first ticket drawn will be a pink ticket? Now, to work this out, what we need to do for probability pink, we essentially want to know what are the chances that we get a pink ticket out of total tickets. Now, we know that we have 50 pink raffle tickets. So there are 50 pink ones out of the total number, we have 50 pink plus 75 yellow. So we add 50 plus 75 to get the total tickets. So 50 plus 75 is 125, sorry. So the chance of drawing a pink ticket is 50 out of 125. If we put this into our calculator, our answer is 0.4. We are told to give our answer as a decimal, so over here we would put 0.4. Moving on to question 6, we are given a chart showing finishing times of marathon runners. A report states that most of the runners finished in under 4 hours, so the line for 4 is here. Most runners finished within this side, the left-hand side of the 4 line. Is the report correct? Explain your decision. Now, with this, just by visualizing the report and the graph, we know that this is not correct. The answer is no. There are multiple explanations that you can give in this case. So one explanation could be that the data is skewed to the left. Another one you could say is that most of the runners, if you actually take into account the runners over here, most of them finished after 4 hours. Or you could simply just say that the right-hand side of the 4 line, so this side over here, is actually larger than the left-hand side. So we can already tell just by visualizing and looking at the graph that the report is not correct. Moving on to question 7, we are told that a shop has a sale and there is 30% off all black tag items. So 30% off gives us a reduced price of £21. One day this notice appears in the shop. One day only, black tag, an extra 25% off marked reduced price, better than half price. A customer complains that this notice is misleading because it is not true. Is the customer correct? So essentially what we want to know is, if we have 30% off and then we get an extra 25% off, is this actually better than half price, or is the customer correct that it is not better than half price? So let's start off by working out what the original price is before the 30% off. So for the original price, we know that the 30% off value gives us 21, which means that the original tag, so we'll say the original price X times by 0.7 equals 21. So to find the original price number X, we do 21 divided by 0.7. This is equal to £30. So the original price of the item is £30. Now, half price of £30 is £15. So what we were trying to figure out now is, once we get the 25% off the reduced price, do we save more? So half price of the item, we'll put in here half price is equal to £15. Now, our new price here is £21. So what we want to work out, I'm just not using these boxes here because there's not enough space. Working out the £21, we want 25% off this £21. So to do that, we do £21 times by 0.75. The reason it's 0.75 is because if we're getting 25% off, we're paying 75% of the price. So 75% is 0.75 as a decimal. This is equal to £15.75. So now we had 30% off £30, which means the item was reduced to £21. And after the £21, we get another 25% off. It's reduced to £15.75. This is not better than half price because half price is £15, which is what we could have paid. So in general, if we do 30% off, we pay 70%, and when we reduce that by an extra 25%, we pay 75% of the new price. So essentially it's 0.75 times by 0.7 which is 52.5% that we're paying. So in terms of the decision, the customer is correct. Moving on from this one, we have question 8. A craftsman uses resin to make a paperweight. He makes the paperweight from two parts, a hemisphere and a cylinder. He uses this plan. How much resin does he need for both parts? So essentially what we need to work out is the resin needed for the hemisphere plus the resin needed for the cylinder. Now he's given us V here, which is the volume of the hemisphere. So what we need to be working out is the volume of the hemisphere here plus the volume of the cylinder. So the volume of the hemisphere given to us in that equation is 2/3 pi r cubed. Now we need to substitute our values in. We have 2/3 times pi is given to us over here as 3.14. So we do 3.14 and times by our radius cubed. Now over here, the full length is 6 centimeters. So the radius would be half of this. So the radius is 3 centimeters. So we have 3 cubed. Putting this equation into our calculator, this gives us 56.52 centimeters cubed. This is the volume of the hemisphere, so the resin needed for the hemisphere. Now we also need to work out the volume of the cylinder here. A volume of a cylinder is the area of the front face times by the height. So this is equal to pi r squared h, because the area of a circle up here is pi r squared times by the height h, which gives us the volume. Now, using this equation, pi r squared h, we have pi as 3.14 from before. We have r as 3, the radius is 3 squared, because we worked that out from up here. And the height of the cylinder is 5 centimeters, so h is 5 times by 5. Putting this into our calculator, we get 141.3 centimeters cubed. So to work out the resin needed for both parts, what we do is we add 56.52 plus 141.3, and this gives us 197.82 centimeters cubed, and this is our answer that we put into here. Now, moving on from this, we have question 9. A gardener wants to build this greenhouse in the top right-hand corner of her garden. This is a sketch plan of her garden, and this is the greenhouse, 2 meters by 2.5 meters. I'll just give you guys a moment to just read this, take into account the numbers. Now, we are told that she's going to leave a 50 centimeter space between the greenhouse and the edge of her garden. She wants a scaled plan of the garden showing the position of the greenhouse. So essentially, if we were to put the greenhouse anywhere here inside, this is a plan of her garden. She wants a 50 centimeter gap between the edges. So it will start from, let's say, here. There's like a little rectangle. So she wants a scaled plan of the garden showing the position of the greenhouse. Draw this scaled plan and put your scale on the plan. Now, to start off, she's working in centimeters here, and our scale that we have here on our graph paper is also in centimeters. So what we're going to do is we're going to convert all of our values into centimeters. So this over here, 5.5 meters, is the same as 550 centimeters. Same over here, 550 centimeters. 2.5 meters is 250 centimeters, and 4 meters is 400 centimeters. Now, the scale we can use is essentially just dividing these values, but making it so it's not too small on the graph. So the scale I would suggest in this case would be 1 to 50. Now, if we do 1 to 50, what we do is we divide all of these values by 50 and work with what we have left for our scale. Now, changing the colour of my pen, I'm just going to divide all of these values by 50 just to see what we're working with. So 550 centimetres divided by 50 leaves us 11 centimetres for us to work with as this top value here. The same over here, so this is also 11 centimetres. 250 centimetres divided by 50 gives us 5, so this over here is 5 centimetres. And the final value here, 400 divided by 50, would give us 8 centimetres. So what we're going to do is we're just going to draw this down below over here. So what I'm going to do, I'm just going to start from this line over here. So for the drawing, maybe I can actually get some shapes and some lines just to make it easier for us. So starting from this point, we have 1 centimetre, 2 centimetres, 3 centimetres, 4 centimetres, 5 centimetres, 6 centimetres, 7, 8, 9, 10, 11. So our first line at the top is 11 centimetres, starts from there. Now going up, this is also going to be 11 centimetres. So drawing down from there, we're just going to count once again and draw. So I'm just going to start from there. Oh, maybe without moving it, I'll just do another drawing. So starting from there, we have 1, 2, 3, 4, 5, 6, 7, 8. I'm going to keep going from there only because I didn't manage to finish. So 8, 9. I think I miscalculated. Let me just count those again. So 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11. Fantastic. Now on the plan here, this is going to be 5 centimetres, so we'll just start from the right hand side here and just draw 5. So 1, 2, 3, 4, 5. This line ends here. And then this one over here is 8 centimetres, so we're going to go down and draw 8. So 1, 2, 3, 4, 5, 6, 7, 8. Now to finish it off, we need to know the lengths over here and the lengths over here. So if this is 11 centimetres, the top one up here, and this is equivalent to 5 centimetres, this line over here would be 11 minus 5. So this is going to be 6 centimetres long. So drawing our 6 centimetres in, we have 1, 2, 3, 4, 5, 6. Now we can already see to connect these, we need 1, 2, 3 centimetres. So to double check that we're correct, we're going to just minus these values here as well. So we have that this line over here is 11 centimetres and this one up here is 8 centimetres. So this line that we need now here would be 11 minus 8, which is 3. So we are correct with our current diagram. So continuing our drawing now, I'm just going to start from the bottom and just combine and connect these. So what we've just done is we've drawn in a scale plan for the actual garden. Now she says over here that to draw her greenhouse, she's going to leave a space of 50 centimetres. So to put her greenhouse in here, I'm just going to give you a rough little example. So I'm just going to change the colour of my pen back to black and go into the shapes and just draw a basic little rectangle. So starting from, started that off as a little red one, which we don't want. We want that to be black, so I'll just get rid of this for now. Or we'll just leave it red. So we have, actually maybe if I just put a square in, it'll be easier for us. So I'm just going to draw one from here. Perfect. Now this is her current one, so she has 2.5. So just going back into my pen, this up here is 2.5 meters and this side over here is 2 meters. Now what we want to do is we want to convert this as well into centimeters. So converting into centimeters, changing the color, 2.5 meters as centimeters is equivalent to 250 centimeters, and this 2 meters here would be 200 centimeters. Now, because we had our plan to scale 1 to 50, I'm just going to draw in a new rectangle and get the plan that we need for our actual garden. So I'll just put one here without compromising the space too much. Now, the 250 centimeters divided by 50 is going to give us the scale for our drawing here. So what we want is 250 centimeters divided by 50. We have 5 centimeters up here. And for this side, it's going to be 200 centimeters divided by 50. This is going to be equivalent to 4 centimeters. Now, we also need to scale in the gap that she's going to leave. So she said over here that she's leaving a gap of 50 centimeters. Just wanted to clear that little space just to make it clearer. So because she's leaving a gap of 50 centimeters, on our plan, what we do is 50 divided by our scale of 1 to 50. So 50 divided by 50 is 1 centimeter. So in our actual drawing, we're going to be leaving 1 centimeter off the edges. Now, if we leave 1 centimeter off the edges, I'm just going to put my plan to blue for now. This means that this is 1 centimeter here, and the edges are 1 centimeter there, or the edges from this side are 1 centimeter here. So let's say her greenhouse, if we leave it 1 centimeter from the edges, it can start from around here. I'll put a little point, because this is 1 centimeter away from this edge and 1 centimeter away from that edge. So what we need to draw in here is this scale that we've just condensed down into this over here instead. So going back into our lines, I'm going to put a blue line in for, well, a blue box in for the actual greenhouse itself. The scale that we want is 5 centimeters lengthwise here, so just counting 5 points and going down. Oh, I do apologize. Maybe I should have just drawn the square in as well, just to make it a little bit clearer. I'm going to click off it and go back into drawing our square. And then starting from here, this is going to be 4 centimeters long, so 2, 3, 4. And then we'll do the exact same on this side, 1, 2, 3, 4. And then what we do is we just connect these, which if you count is going to be 5 over there as well. So putting all the correct lengths into our diagram as well, we know that this over here is our greenhouse. So we have from our scale up here that this length here is 5 centimeters. Oh, I'm so sorry, I'm in my drawing side again. So we'll just go back into the pen. This is 5 centimeters. This is equivalent to 4 centimeters. And then for our actual garden, this was 11 centimeters. This edge here was also 11 centimeters. Down here we have 5 centimeters. We have this side is 3 centimeters. This side is 6 centimeters. And this side is 8 centimeters. And these are just from our previous calculations, but if you do get confused and after you finish drawing and you have to put your lengths in, just count. So we have 1, 2, 3, 4, 5, 6, 7, 8, and you just do those for all the sides. Now that is the answer for this question. So moving on now, and going back into a black pen. The next question is question 10. A student wants to raise £100 for charity. He will sell hot dogs at a disco and make 150 hot dogs. He buys ingredients at the supermarket where hot dog sausages, a tin of 8 costs 50p, and for the buns a packet of 6 costs 90p. If he sells all the hot dogs, what is the minimum price he must charge to make a profit of £100? So to work this out, essentially what we want to figure out is if he's selling 150 hot dogs and he wants to raise £100 for charity, we want to figure out his costs plus £100 and divide that by the 150 hot dogs just to see how much he should be charging. So let's start off by figuring out his costs. So to make 150 hot dogs, and each tin has 8 hot dogs, we're going to divide 150 hot dogs by 8 just to see how many tins he needs. So for the tins, 150 divided by 8 means that we need 18.75 tins. We can't buy a 0.75 of a tin, so he needs to buy 19 tins. So 19 tins. With the tins, they cost 50p each. So if we times that by 0.50 pounds, this is equivalent to £9.50 for the hot dogs themselves. Now we do the same for the buns. So 150 divided by 6 buns in a packet will give us how many packets we need to buy. So 150 divided by 6 is equal to 25 bun packets. So these 25 buns times by 90p or times by 0.90 pounds means that for the actual bun packets he's spending £22.50. So his cost will be the £9.50 for the actual hot dogs themselves and £22.50 for the buns. So adding these together, his costs will be £9.50 plus £22.50, which is £32. So in this case, if he wants to raise £100 for charity, we want £32 as his costs plus £100 extra on top, which is what he's aiming to raise. So he's aiming to make £132 from 150 hot dogs, because we were told up here that he's going to make 150 hot dogs. So to figure out how much money he's going to charge per hot dog, what we do is we take this £132 for the costs and the £100 profit for charity, and we divide it by 150 hot dogs. So if you put that into your calculator, you do get £0.88, which is equal to 88p. So you can put 88p here, or you can put it as pounds, which is 0.88. Moving on to question 11. A supermarket buyer compares large eggs from 2 suppliers. She wants to buy the largest eggs, and the table shows the masses of a sample of large eggs from supplier A. A similar sample taken from supplier B gives a mean value of 66.5. Which supplier should the buyer use? Now, for this one, to start off, at the top here we have a frequency table. So what we're going to do is we're going to also figure out a mean value for the eggs from this frequency table, and we were already given one for B. So to find the mean from a frequency table, what we do is we first find the midpoint of each of these classes. So we just want the middle value. So to get the middle value for the first one, for example, we do 63 plus 65 divided by 2. The second one would be 65 plus 67 divided by 2. 67 plus 69 divided by 2, and so on. So for each of these now, if we were to just put some little lines in, this one here would be 64, this one here would be 66, this one here would be 68 as the midpoints. 69 plus 71 divided by 2 would be 70. And the last one there will be 71 plus 73 divided by 2, we get 72. Now, these are the midpoints. So then what we do is we take the corresponding frequency and we multiply them. Then what we do is we sum up all the products and divide by the total number of frequencies, and that gives us the mean. So what we want now is we're essentially going to do 64 times 22, 66 times 27, 68 times 26, 70 times 15, and 72 times 10. So we'll start off by 64 times 22. That's 1,408. Then we add the next value. So the next value would be 66 times 27, which if we put into our calculator is 1,782. Then we add the next one, which is 68 times by 26, which is 1,768. Then we do 70 times 15, which is equal to 1,050. And we add the last one up here, which is 72 times by 10, so 720. Now, adding all of these together, we get 6,728. Now, like I mentioned earlier, to figure out the mean value, we divide this total number here now by the number of frequencies. So 22 plus 27 plus 26 plus 15 plus 10. So in total here, the sum of the frequencies is 100. So we do this divided by 100, so 100 eggs in total, and the mean in grams would be 67.28 grams, and this is supplier A. We're told here that the mean value for B is 66.5 grams. She wants to buy the largest eggs, so in terms of weight, supplier A's eggs weigh more. So 67.28 equals A, which is bigger than the 66.5, which is B. So on average, if you were to subtract these, your explanation here, what you would write is that on average, supplier A's eggs weigh 0.78 grams more, because 67.28 minus 66.5 equals 0.78 grams more for A. So the supplier that we would go for would be supplier A. Moving on, for question 12, a man has £5,000. He will put his money into a savings account at a bank and wants to save it for 1 year. Bank A pays 2% compound interest and adds interest every 6 months. So to get to 1 year, we already know that we're going to be calculating this twice to get to 1 year. And Bank B pays 3.15% annual interest. Which bank should he choose? So starting off with A, we have his original £5,000, and then the compound interest is 2%, so we times that as a 2% increase, we times it by 1.02, because 2% as a decimal is 0.02, but we times it by the 1 because it's an increase on top. We're not trying to figure out 2% of this, we want 2% on top of this. So this would be equivalent to £5,100 in the first 6 months. We also want the next 6 months to get it to be 12 months, which is 1 year. So what we do is we take this and times it by 1.02 as another 2% compound interest to get it to the compound interest at the end of the year. So times that by 1.02, and at the end of the year, the amount he will have in his bank will be £5,202. That's for A. For B, we have the same figure, his original £5,000, and we times that by a 3.15% annual interest rate. So that's 1.0315, because again, 3.15% as a decimal is 0.0315, but we want an increase. So this is the value we put into our calculator, and what we will end up with is £5,157.50. Now, which bank should he choose? He should choose Bank A because at the end he has more money left over. So Bank A, and that would be the explanation that we write here. We can say that 5,202 is larger than £5,157.50, so he should choose Bank A. Moving on to question 13. We are given that a magazine article has this headline: Garden birds are in decline, fewer birds seen in our gardens. An environmental organization records information about bird populations. The graph shows some data about 2 types of garden birds. So we have the X's or sparrows and the circles are chaffinch. The average number of birds seen on this axis, and we have the year on the bottom axis. Is the magazine headline correct? Show suitable calculations of percentage changes for the last 10 years and draw trend lines on the graph to support your answer. Explain your answer and make 2 comments. Now we'll start off with the trend lines. So for a trend line, what we want is approximately the same number of plots either side of the line and the line going through as many of these points as we can. So because I can't really use a ruler on this, I will try to make it as accurate as possible. So instead of doing the measure, I'm just going to do a normal line. So going through our plots, on average, just with my mouse, I'll show you, we want it to go roughly around like this. So I'm just going to start from this point here. I'm going to move my line and try get as many of these points in as possible, and roughly the same amount going through. So if I do this, we go through, I'll leave it like this for now. So we go through this one, this one, this one, and that one. And we have 1, 2 plots on this side, well 1, 2, 3 plots on this side, and we have 1, 2, 3 plots on the other side. So this is roughly a good line to draw. Now we'll do the same for this line over here. So starting from this point, I'm going to go through and try to get as many points as possible covered. So maybe even like this. Something along those lines. And we have a similar amount of points left on the left-hand side as on the right-hand side, and going through as many as possible. Now, this is going to be our trend line. Going back into my pen, we were also asked to show suitable calculations of percentage changes over the last 10 years. So it starts off with 2008, but we don't really have any figures for then. We have figures starting from 2009 until 2018. So if we look at the trend, for the first bird, we started off in 2009 seeing around 4, and in 2018 this dropped to 2 birds seen. So to go down from 4 until 2, there's been a 50% decrease in these type of birds. So we would say that the chaffinch bird started at 4 bird sightings in 2009 and ended at 2 bird sightings in 2018. So there's been a 50% decrease. Now, checking the same figures and same dates for the sparrow, in 2009 we would see 5 birds, and ending off in 2018 we again see 5 birds. So there's been a 0% change for the sparrow. So the comments that we could put here as 2 comments would be that there's been a decrease in chaffinch sightings, so 50% decrease since 2009 until 2018. And the second comment can be that sparrow sightings roughly remain the same, a 0% change since 2009 and going on to 2018. So is the magazine headline correct? It is correct for the chaffinch bird, but isn't that correct for the sparrow? The sparrow sightings are roughly the same. Moving on to question 14, a team manager wants to pick 4 people for a bowling competition. She decides to pick players with consistently good average median scoring performances. She picks the following 3 people. She needs 1 more player to make up the team, and she looks at the scores of 2 more players. So we have Dave and Elaine. Make suitable calculations for Dave and Elaine and decide which player best fits the requirements. Explain your decision using figures. So starting off, she's using median, so we'll also calculate the median for Dave and median for Elaine. So starting on the left-hand side for Dave, to work out the median, what you can normally do to make it easier is start with either the lowest number or the highest number. So we'll start with the lowest in this case and just list them in order going from smallest to biggest. So we have 48, get rid of that one. The next smallest one is going to be 67, followed by 78, followed by 86. You can cross these off as you go. So 67, 78, 86, then we have 96, 98, 101, and 102. So to work out the median, what you would be doing is you'll cross off the smallest and the largest, cross off the next smallest, next largest, next smallest, next largest. And when you have 2 numbers left here, you add them together and divide by 2. So 86 plus 96 divided by 2. And this gives us 91. So Dave's median score is 91. And we're going to do the exact same here for Elaine. So we have 79, then we have 84, and again, just cross them off just to make sure you've actually incorporated all of them in. Then we have 87, another 87, Then we have 93, 97, 98, and 101. Now we'll do the same crossing out method, so smallest, largest, smallest, largest, smallest, largest, leaving us with 87 and 93. So what we do is 87 plus 93 divided by 2. And the answer we have left for the median score for Elaine would be 90. So we have median score for Dave as 91 and median score for Elaine as 90. Now if we look at the table and the people she's picked, she has their median scores listed here, but she also has their range of scores over the last 8 matches. So what we need to do is we need to calculate the ranges for Dave and ranges for Elaine. So for the range, what you do is you take the largest number, so 102, minus the smallest number, which was 48. So 102, I'll just do at the very top here, minus 48 is equal to 54. So the range for Dave is 54, and for Elaine we have 101 minus the smallest number of 79. Her range is equal to 22. So down here in our actual box, what we would put in, so Dave range, I'm so sorry, the stylus is a little bit dodgy at times, range equals 54, and then we have Elaine's range equals 22. Now with their mean scores, well their median scores, sorry, taken into consideration as well, we need to make a suitable calculation for who she should choose. Now the answer that I would put here, and the correct answer in my opinion, would be Elaine. And the reasoning behind this is when we factor in the median values and the ranges, Elaine is more consistent because her scores are closer together. So you could say Elaine is more consistent as her range is 22, which is smaller than Dave's range of 54. And her median score is 90, which is similar to Dave's median score of 91. There isn't much difference between them. So they're roughly scoring the same, but she's more consistent with her results. So the correct answer here would be Elaine. Moving on to the next question, we have question 15. Question 15 says that a fisherman sets off from Dunsey in a boat. His boat will travel at an average speed of 5 kilometers per hour. He has this map so he can avoid the rocks. So he's going from Dunsey. He needs to meet up with a ship at coordinate L34 at 5 p.m. He needs to know at what time he must leave Dunsey. So first of all, let's plot L34 here. So going down from L onto our line 34, we're looking to go here. So on this point is what we're looking to do. So avoiding the rocks, let's plan out our travel. So what I'm going to do is I'm just going to draw the lines here just to make it easy for us to count how many centimeters is going to be traveling, and then use the scale over here to make it to scale. So going up from here, we have 1 centimeter, 2 centimeters, 3 centimeters, up until here. And then from here, to get from there to there, I'm just going to go backwards only because it makes it easier to draw. We have 1, 2, 3, 4, 5, 6, 7, 8. So that was 3 here and 8 there. We're already on 11. So going from here to here, we have 1, 2, and that's the 2 centimeters there. So let me just write these in. So we have 3 centimeters on this side, 8 centimeters up here, and then 2 centimeters here. So adding these together, he's traveling 13 centimeters. Now, if you cross-reference this with the mark scheme says that you can do anywhere between 12 centimeters to 15 centimeters because you may choose to go a little bit higher to avoid the rocks completely, or just the way you travel could be different. But for this example, I'm just going to use the calculation of 13 centimeters. But if you did get 12 or you did get up to 15, it is still correct. So anywhere between that range. So if he's going to leave and get here by 5 p.m., what we need to know is Well, we need to start off with converting the 13 centimeters traveled on our map to the actual map that he's going to be using. So we do 13 centimeters times by 25,000 to get the actual centimeters. So starting here, we have 13 times by 25,000, which gets our real centimeter scale, which is equal to 325,000 centimeters. Now, up here, we were told he's traveling at 5 kilometers per hour. So what we need to do is we need to change these centimeters into kilometers. So let's start by converting this into meters. So centimeters to meters means divide by 100. So dividing this by 100, this is equal to 3,250 meters. Now, transferring meters into kilometers, we divide by 1,000. So this divided by 1,000 is equal to 3.25 kilometers. Now, we were told that he's traveling 5 kilometers per hour. Now, transfer this into minutes if needed. That's 5 kilometers per 60 minutes. Now let's figure out 1 kilometer per 60. Well, if 5 kilometers is 60 minutes, we figure out 1 kilometer. So 1 kilometer is equal to 60 divided by 5. So that's 12 minutes. We can see here that he's traveling 3.25 kilometers. So what we do is 3.25 kilometers is 12 times 3.25, and that will tell us how many minutes it will take to travel this far. So 3.25 times by our 12 minutes gives us 39 minutes. So we know that he must get to L34 by 5 p.m. So in order to get there for 5 p.m., his journey takes him 39 minutes. We do 5 p.m. minus journey time. So 5 p.m. and total journey of 39 minutes means that he needs to leave at 4:21 p.m. because 4:21 plus the 39 minutes will get us to 5 p.m. So the correct answer here is going to be 4:21 p.m. Now moving on, this is just spare paper and extra working out space. So this would be the end of the calculator paper.